Hi. All right. So in this video, I'm going to be explaining the question that's on the screen right now, which is from Prep Test 82, Section 2, and it's number 17. And this one falls into a category that can be called the paradox question type or resolve, reconcile, explain. What we have is a particular set of statements, usually. And within those statements, there's kind of this like unexpected twist. And then what we're trying to do is explain why that is, right? So in this case, they actually identify what the unexpected twist is, and that's the tendency of corrections in this particular field of study to favor a particular theory. Um, so let's go to the stimulus and see what they have for us. And just a note, like one of the reasons that I do read the question stem first is because it's going to give me a clue about whether I'm dealing with an argument in the stimulus, and most of the time I will be, or I'm not dealing with an argument and I'm actually just dealing with a series of statements or pieces of information. So if I have an argument, I'm going to be looking for the structure of that argument, right? I'm going to be looking for what's the conclusion, what are the premises that support that conclusion, and the flaw usually, which is why don't those premises prove the conclusion. So yeah, if I know that I'm not really dealing with an argument, then I don't have that in mind, like that idea of like, oh, I have to identify the parts of this argument. I have to identify how this is flawed. And so I can actually go into the stimulus with a job in mind to a certain extent. And so while I still want to read the stimulus with a bit of an open mind, I'm not like identifying parts or um, looking for transition words because I want to make sure that I don't miss a word that indicates the part of an argument, right? So here I know that there's going to be a bit of a turn, you know, they're going to start out just giving me some information, and then they're going to kind of um, bring up this point that's unexpected. Yeah. So the question stem kind of gives me an idea of what to expect. Another thing that the question stem can tell me, so within argument stimuli, some arguments are going to be flawed. Most arguments are going to be flawed, but sometimes the argument's not actually flawed. And so I don't really want to waste time on those ones searching for a flaw that doesn't exist. Um, and so, like, for example, the ones where I'm being asked to identify the conclusion, those ones I don't need to search for a flaw. I don't really need to waste my time doing that. I'm more concerned with structure. Same with when they ask what role is being played, that's a structure question. If I'm being asked what the method of reasoning is, or it might, the question stem might say the argument proceeds by, and then just kind of leave me there. That one's also a structure question. And then within parallel type questions, or ones where we have to match the stimulus to one of the answer choices, there are ones where we're just matching the reasoning, and there are other ones where we have to match the flawed reasoning. So if the question stem doesn't say that we're trying to find like similar flawed reasoning, then it's really just a matter of structure. And with the flawed reasoning ones, we want to actually identify the flaw in the argument before we go to the answer choices. So yeah, so I've definitely heard um, two different recommendations when it comes to reading the question stem first, right? So some people recommend it and some people don't. And they give their reasons for and against. And I fall into the camp that says you should read it first. I think especially when you're studying untimed, it's good to read it first. It's also good to do a bunch of like similar question types um, together and start to notice some of the patterns that occur with those question types. You don't want to rely too heavily on patterns, and be a bit careful about like how um, it's patterns in reasoning, not just patterns in like certain words or you've got to be careful that you are still analyzing to a bit of a depth, that you're like not just looking at the surface language, but looking at the meaning and the connection between ideas and stuff. But I do think that can be helpful, and I think with the LSAT, having a lot of experience with the questions does help. Certainly, it's very important to review the questions that you do and get the most value out of them. There's really not much point in just doing tons and tons of questions and I'm going on like a complete tangent here, but there's not much point in just doing a bunch of questions, checking to see if you got them wrong or right, and then moving on. Like when you get things wrong, it's really important to review them. And then there's also something that I recommend, which is called a blind review, which I'm definitely not the first person to come up with this or recommend it. I think I saw a bunch of articles on Seven Sage about doing a blind review, and I realized, I guess, that was something that I had actually been doing in a way, because when I was doing untimed prep, I would like force myself to kind of sit with things until I was actually convinced that I had come up with an answer that I was happy with, and then I would check to see if I was right, rather than just doing it under time pressure and then checking the answer and then going back only if I was wrong, I guess. So with blind review, basically you would do a test under the time pressure, and then rather than just checking your answers and going over the ones that you got wrong, you would redo that test from start to finish without knowing whether or not the answers that you chose were correct, and you would give yourself as much time as you needed, even coming back for like another study session the next day or something, and really spend a lot of time with the ones where you're unsure. And also, rather than, so let's say you're guessing between two answer choices, and you're guessing between A and B, and then you've got it down to a 50-50, and you go, okay, well, because I don't have enough time, I'm just going to go ahead and pick A and I'm going to move on. With a blind review, you would still flag that question as one where like, I actually don't know what I think the answer is, right? And so in a regular review, let's say you just guessed out of that 50-50 shot, you guessed and you got it right, then you wouldn't end up reviewing that question, even though it was one where you didn't have a solid understanding of what was going on. And half the time you would get a question like that wrong because you were still just guessing and you still just had that 50-50 shot. So yeah, it forces you to review questions that you otherwise wouldn't. Okay, so I am gonna actually get to this question. I'm sorry, I'm just talking. Okay, so a scientist says that a number of errors can plague a data collection process. Since examining the collected data enables researchers to detect many of these errors, it is standard practice for researchers to correct collected data. Okay, so let's just kind of try to understand what that is saying before we move on, right? Like, do we really know what's going on there? A number of errors can plague a data collection process. So one of those errors might be like typos, right? So maybe, as someone's just like, putting numbers into a spreadsheet, they accidentally like add a zero when they shouldn't have added a zero, or they forgot, whatever, or they added like a letter in there. And so it invalidated that data point because it was supposed to be just numbers, or, like there are lots of different mistakes that could happen. But yeah, typos would be one type of error that you might have with data collection, and I'm sure there are plenty of others. But you could go back and examine that data for typos, and maybe you'd be able to detect that that's an error. You could actually check back to the sample that corresponds to, and go, okay, yeah, like it shouldn't have been 500, it should have just been 50, something like that, right? So when they say it's standard practice for researchers to correct collected data, this isn't something that is questionable on its own, right? So the idea with this type of question is that we're trying to like resolve something. And in these first two sentences, we don't have anything that needs to be resolved, right? Then we get to the word however, and so of course now this is where we have that twist, and here's the part that we have to explain. However, in my field, says the scientist, there is a striking tendency for such corrections to favor Jones's theory. Okay, that is, the majority of corrections result in the corrected data being closer than the uncorrected data to what Jones's theory predicts. Okay, so there are a few explanations that I could kind of brainstorm for why that might be the case. So when we correct the data, it tends to be closer to what Jones's theory would predict than when we don't correct the data. So possibly that's because Jones's theory is correct, right? Like it could just be that simple, that Jones's theory is correct. Therefore, when we correct the data, it falls more in line with what Jones's theory would predict. It could also be that in that field, Jones's theory is something that like everybody who works in that field is aware of. And so they have like a bias where they would be kind of on the lookout for things that would conflict with Jones's theory. And so either in kind of like a sinister way or in just a completely unconscious way, they are picking out the data points that deviate from Jones's theory. So if Jones's theory predicts a correlation between A and B, where, if A is small, B is also small, and if A is big, then B is also big. And there's like a trend line that tends to go upwards on a graph where we have A on the x-axis and B on the y-axis. Then yeah, I mean, if we have a data point that's like, low B but really high A, then that's like an outlier where it's just going to be more obvious. And that could be because that data point is not correct, like it doesn't actually represent the data that was collected. Or it could be that data point actually just is an exception to the theory. And while the theory predicts that generally we're going to have this trend, there may be sometimes where that doesn't happen, right? Like some exceptions to that rule. So, yeah, but we're trying to explain why the corrections tend to favor Jones's theory, and there are multiple potential correct answers to that question. Obviously, there's only one correct answer in the answer choices that we get, but that doesn't mean that there's only one correct answer that we can like pre-phrase, right? So sometimes when you read the stimulus, you might predict that the answer is going to be one thing, and then that turns out to not be an option. And that doesn't necessarily mean that you've misinterpreted the stimulus. It might just mean that you have imagined an answer choice that is, is another correct answer choice. So when we go through the answer choices, we have to be careful that we don't eliminate them just because they're not what we predicted, and we want to give them a chance. And I don't think that like invalidates or devalues the process of reading the stimulus and trying to predict what the correct answer is. Okay, so all of that to say there are a few different things that might help to explain that tendency, but we'll see what they offer us. So A, researchers normally give data that is in line with a theory the same weight as data that conflicts with that theory when they are determining whether to accept that theory. So here talking about like the weight that they give data that is in line versus that's not in line, and trying to decide whether or not they're going to accept the theory. We already know like what's happening to the data when the corrections are happening in the data collection process. So this is A is kind of talking about it like a different stage in the process, right? So this would be like when the data is like published, I would guess, and also the fact that like this is saying that they're giving data that aligns and data that conflicts the same weight doesn't really help me explain the tendency of corrections to favor Jones's theory. So I would eliminate this one for now. These little guys changed recently, so now they're like little eyes. So I'm basically just saying like, I don't want to see that right now. And it doesn't mean that I can't come back to it if I don't find anything else that's helpful, but that one doesn't strike me as particularly helpful in explaining the corrections aspect. Okay, so B, researchers in this field. Okay, so talking about this field specifically, that's another thing actually that this one wasn't that great about. Like it talks about researchers normally rather than like this specific field and Jones's theory in particular. So it's a little bit too general. B, researchers in the scientist field give data that conflicts with Jones's theory greater scrutiny than they give data that is in line with Jones's theory. So that's really interesting, right? That to me means that if the data conflicts with Jones's theory, then they are going to pay a lot more attention to it, and they're going to scrutinize it. So they're going to check it, right? They're going to actually check it for mistakes, right? So to give something scrutiny, it's you're going to look at it carefully and potentially like with suspicion. So if there are errors in data that conflicts with Jones's theory, then they're going to find them. Whereas maybe there are some errors in the data that is in line with Jones's theory that they just kind of miss because it's kind of like, it's like that outlier example, right? So if you have a trend line and you have a bunch of things that are very close to that trend line, but then you have a few outliers, if you're more likely to double check the outliers, then if you actually find an error in one of those data points, so like if you go back and you go, oh yeah, this shouldn't be 500, this should be 50. Like if you just find like a regular typo in one of those outliers, and then it brings it into line with Jones's theory, or brings it, even a little bit closer to the trend line, then that's going to, like, that process happening over and over would definitely explain a tendency of corrections to favor Jones's theory. And then maybe something that's like on the trend line, um, there are so many data points that are on the trend line. And so maybe it just gets kind of lost. Like, you have a bunch of um, points that are like, 43, 43, 43, and like maybe one of those 43s was actually supposed to be like, I don't know, 33 or 43.5 or whatever, and it just got kind of missed, um, then yeah, like that would be much more likely something that gets overlooked in the process of correcting the data. So B definitely does help and does explain that tendency. C, researchers in the scientist field are more likely to pursue lines of research that they expect will favor theories they accept than to pursue other lines of research. So the interesting thing about this is that we actually don't know if researchers accept Jones's theory. Like that's actually never mentioned. The corrections just tend to favor Jones's theory. We don't know if these researchers accept it. So this isn't really going to help us. But also, this has more to do with like what questions are they asking with their experiments? Like what lines of research, right? Like that would be like directions that you would take your research. So questions that you would ask and that you would try to figure out the answers to those questions, or you would hypothesize something in a particular area. So the likelihood that they're going to ask questions where they think the answers are going to favor a theory they like is a different issue from after they've already collected data trying to answer a particular question, how they correct that data, how they go about correcting that data. It's a very different part of the process. Kind of like how A is a different part of the process as well. It's like not the right point in time in the process that we're dealing with. So this one we'd also have to eliminate. D, even if researchers fail to detect errors, that doesn't guarantee that the errors don't exist. I mean, that may be true, but does not help explain why, when errors are corrected, the corrections tend to favor Jones's theory. So, yeah, that one's out. Like it's possible that the only reason that the corrected data tends to be closer to Jones's theory than the uncorrected data is because Jones's theory is correct, right? There might be like absolutely nothing untoward going on in this situation. It might just be that Jones's theory is right. Okay, E, researchers in the scientist field have formulated several other theories. Absolutely, like not necessary and doesn't explain why the corrections would favor Jones's theory. The other theories, yeah, is actually irrelevant here. So B has got to be the correct answer. Okay, and we're there. And I took a ridiculously long time explaining that one question. My apologies. I went off on a tangent there. So yeah, if you have the patience to get through all of that, then well done. I'll make a little timestamp in a comment or something. Yeah, okay. All right, I'll do question 19 in another video. So yeah, if you're wanting to look at that, then I'll see you in a second.